We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the argument principle from the section Complex Analysis. And this question is from section B, that is a multiple choice question, one answer only, bearing the question ID is 704034. Before discussing the given question and its answer, let us familiarize few concepts here. The first one is, what is a meromorphic function? A function f of z is said to be meromorphic in a domain D in the complex plane if it is analytic throughout D except for poles. It is analytic throughout D except poles. That means it is the function f of z is analytic throughout D and will have only poles and no other types of singularities. Only poles will be there. Such a function is said to be a meromorphic function. And we have the famous argument principle for meromorphic functions. Let C be a positively oriented simple closed contour. C is a positively oriented simple closed contour, and suppose that the hypothesis is A function f of z is meromorphic in the domain interior to C. So interior to C, the domain is there. In that, the function f z is meromorphic. That means it is analytic throughout the interior of C except for poles. B, the condition B, f z is analytic and non-zero on C. So what happens on C? What happens? F z is analytic and it is non-zero on C. That means for no point on C, f of z vanishes. Condition C, counting multiplicities. So suppose a 0 is repeated 3 times, then you have to count that as 3 zeros. Suppose a pole is repeated 4 times, then it is to be counted as 4 poles. So counting multiplicities, capital N is the number of zeros and capital P the number of poles of fz inside C, then 1 by 2 pi I integral taken round C f prime z by fz dz is equal to n minus p, number of zeros minus the number of poles. That is the famous argument principle. And we will be using this concept and the principle in our given example in the examination. Right. Let's get into the question now. So that is the question, is an argument principle from complex analysis, and it is from the CSIR NET 2023 December question paper, and the QID question ID QID is B, that is for 3 marks, bearing QID 704034. The given question is, let f be a meromorphic function on an open set containing the unit circle C. So there is a open set, let us say D. In that, the unit circle is there, and our function is meromorphic on the open set D, in which this unit circle is there and its interior. Right. Suppose that f has no zeros and no poles on C. So that means on C, f of z is not vanishing and f of z has no poles on C. Right. Let NP and N0 denote the number of poles and the number of zeros of fz inside C respectively. Which of the following is true? We are given 4 options. The option 1. Now, 4 options are given. In each of the options, the value of 1 by 2 pi I integral taken round C, zf prime. Zf prime means the derivative of zf by zf with respect to z is equal to, different answers are given. N0 minus np plus 1, and here it is minus 1. And then option 3, it is just N0 minus Np. In then option 4, it is reversed Np minus N0. So which is the correct? The value of 1 by 2 pi I integral taken round C, zf prime by zf dz, we have to find out from these 4 options. Right. Now, let's now discuss the solution of the problem in detail. We have an open disk D containing the unit circle C mod z is equal to 1. This is the open set D and containing the unit circle C mod z is equal to 1. And in this, fz is meromorphic. Given f of z is meromorphic function on D, that means in this D, f of z is meromorphic, and f of z has no zeros and no poles on C. On C, no zeros and no poles are there. Right. Given N0 is the number of zeros of fz inside C, and Np the number of poles of fz inside C. Right. So now we have to compute this integral. 1 by 2 pi I integral taken round C zf prime, the derivative of zf by zf with respect to z. That's called 1 by 2 pi I integral taken round C. The derivative of zf is z into the derivative of f of z, f prime z, plus f of z into the derivative of z is 1 by zf z with respect to z. Now, let's now separate them. So 1 by 2 pi I integral taken round C, the first one z f prime z by zf z plus integral taken round C f of z by zf z dz. Now that will be equal to 1 by 2 pi I integral taken round C in brackets f prime z by f z dz. That means we are cancelling z here. Can we? That's the question. That's the question. You can cancel this provided z is not 0 on C. Yes. Yes, on C z is not 0. On C z is not 0. Z is 0 is the center of the circle C. So z cannot be. Z is not 0 on C. Z is not. Therefore, you can cancel. Now here in the second integral, we have cancelled fz and we have written integral taken round C dz by z. Can we? Yes. Why? Because fz has no zeros on C. So fz is not 0 on C. On C. See, the integration is round the contour C. So therefore you can cancel that one. No problems. Now we recognize here we can apply our meromorphic function, that is the argument principle. And here we comfortably apply the Cauchy's integral formula. Right. So that is equal to, separate them, 1 by 2 pi I integral taken round C f prime z by f z dz plus 1 by 2 pi I integral taken round C dz by z. Right. And this is the argument principle works here. So it is n naught, the number of zeros of fz minus the number of the poles. So n naught minus np. That is the value here. And 1 by 2 pi I integral taken on C dz by z, apply the Cauchy's integral formula, and that will be 2 pi I. For this 2 pi I, 1 by 2 pi I is outside, therefore 1 you will get. right? So this is equal to n naught minus np, number of zeros minus number of poles, by the principle of argument principle, plus this 1 by 2 pi I. For this 2 pi I again, by Cauchy's integral formula, 2 pi I 2 pi cancels and you will get 1. So the value of this 1 by 2 pi I integral taken around C ZF prime by ZF G with respect to Z is n naught minus np plus 1. Let's look at our options. Right, we have looked at the option 1 only. So this is precisely appearing at option 1. Therefore, the answer to this question is option 1. And that is the detailed discussion of the solution of the problem that appeared in the CSIR NET 2023 December examination. And the question is based on the application of the argument principle. Right. I am sure that you have understood the solution of this problem. And if you like my videos, please like and share and subscribe my videos. I wish you all the best. Thank you.